Sorry, I'm muted. What we discussed earlier in previous session,
Network layer.
network layer. Network layer will work in two different networks. Like here, what is network? We will discuss later. Just now, for time being, just assume like 192, 168, 1.1/24, and this is our different network. 192.168.2.24. In this host, we have like 255 and 253 end users. And this host, we have like 253 end users here. This is called network, one network, one network. And this is our one network. You can assume like this is one LAN set, one of LAN, and this one is one of LAN. The router is like it will be work act as like ISP. For time being, you can assume likewise. This is different network and this one is different network. But now coming to switch. Now coming to switch. This is only one network. This is our only one network. This is a gateway for this all PCs. This is the gateway for this all PCs. Anyway, we'll in our lab we'll discuss it. For time being, switch will work within a network and a router will work in between a in between a networks in two different networks. And here mainly we have two types of protocols work here work like routed and routing protocols in this network layer. In this network layer, two types of routing protocols, routed and routing protocols will work at network layer. Mainly routed and routing protocols, two types of protocols will work. Protocols work at network layer. One is routed and other one is routing protocol. Thus, what is routed and routing protocols? Routed protocols like data carries defined. It will be carry the end user information. Routed protocol will carry the information like end user. And here we have used to carry the data between data means user information, user to user, or for your reference purpose, you can write act as data carries defines logical addressing. It will be like logical addressing. And we have examples like we have two examples here. IPv4 and IPv6 for this. The user information will be carrying. Any queries? Any doubts? For and routing protocols, here it will be select the best path with the help of routing protocols. Here we have like RIP, OSPF, EAGRP, and OSP. These all are we have RIP, routing information protocol, EAGRP, enhanced interior gateway routing protocol, and OSPF, open shortest path first, and one more IGP, IGRP. Nowadays, we are not using interior gateway routing protocols. In the interior IG, these all are like interior gateway protocols only. We'll use for these protocols like LAN side. One more routing protocol we have exterior gateway protocol, that is EBGP, EGP. But this EGP protocol like BGP, Border Gateway Protocol. These all are for the interior gateway routing protocol, and it will be work in within AS number. We'll discuss AS number also later. For time being, its IGP protocols are RIP, EAGRP, OSPF. These all are for best path selection, path determination. Okay, it will be select the best path and send whatever information is there. With the help of that path, it will be send. And here we have load balancing, everything we'll discuss later. And EGP, its exterior gateway protocol, it will be work on layer 7. We have, it is not dynamic routing protocol. Again, it's statically we should have to define. So remove here. Okay, guys, any doubts up to here?
Also.
Okay. And here, which devices will work in this network layer? Router and multi-layer switches. For example of devices, the devices work at this layer are router and MLS, multi-layer switch. Router in the sense we'll discuss later. Routers and MLS. Guys, in network layer, layer 3, it will be here we have routers, switches, and mainly here we have routing protocol. Routed and routing protocols will work. The user information will carry with the help of IPv4 and IPv6 with routed protocols, and with routing protocols here best path selection purpose. If in you have multiple routers, like for example here router 1, router 2, router 3. Anyway, for simple explanation, I am explaining here. Later we'll discuss what is routing protocols. Their end users connected like one. These all are not zeros. These all are routers. One more will take here. One more router. Now this is connected on LAN here, and LAN is connected to one switch, and one switch is connected to some end users PCs. Okay, these all are PCs. These PCs are connected. My screen is visible, right? Everyone?
Yes.
Good. Thank you for confirmation. As this is connected to one switch. How they determine the best path here? See, here we have see here. I'll make it simple. This is R1 and R2. This is our destination is like R3, and here R4, R5, R6. The main network engineer roles is he will always will work a router, switches, and layer one, layer two, not layer one, layer two switches, and layer three devices. Those are routers, multi-layer switches. These work only for our roles and responsibilities. Like whenever your switch went down, just upgrade the switch. This kind of roles only for network engineer. Will if you are lifetime working, in the sense if you have 10 years of experience also, L2, L3 devices only, router, switches, and firewalls also commanders, L3 only, because it will work in between routers, in between two networks, sorry, in between two different networks. That is different, we'll discuss later. These things only. And the network engineer, here if you have L2 engineer means you are data link layer, switches upgradation, switch VLAN, if any VLAN changes required, STP ports are down, port fast down, this kind of roles only. For L3, if any path is not you are getting, OSPF neighborship went down, this kind of troubleshooting only. And if you are upgrading routers, devices, this much only for network engineer roles. We'll discuss troubleshooting also. And here we have RIP protocol for best path selection, EIGRP protocol, and OSPF protocol. And a RIP will work hope count. For best path selection, RIP will work hope count. How many hopes away the device is there? R1, R2, R3. For this is the best path for the RIP. Only between only one hope. But EIGRP will work based on delay, bandwidth, K values. Here we have K bandwidth, delay, reliability, MTU size. These values we'll discuss later whenever we discuss uh, EAGRP that time. If you have like here one Gbps speed, here like you have this is 1 MB, 1 KB, sorry, 1 KB speed. Here also 1 KB. Here 1 MB, 1 MB, 1 MB. Here 1 MB, 1 MB, 1 GB, gig, and 1 gig. Now tell me, RIP will work, how it will be select the best path. Anyone can answer, just randomly you give, no issue.
Number of hopes.
Number of
Hopes.
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 For which one is the best path for RIP?
Like
In between, you can say
R1, R2, R3.
R1,
Uh,
R2, R3. Everyone is right?
I
Yes.
think
R4 and R6.
Who told R4 and R5, R6, R6 for the
Best hops is basically for R4 and R6 because it's 1 MB.
1 MB? Okay, fine. For RIP protocol, right?
Yes.
Okay, fine. And for EAGRP? For EAGRP and OSPF?
Like
Please.
metric value and
Okay, metric value. OSPF for the use metric value, reference bandwidth by interface bandwidth. But EAGRP we have like K values, load, delay.
yeah, delay.
Yes,
Mm.
exactly. K values, K1, K2, K3, K4.
K1,
We'll
K2.
discuss later. Good. But see, a RIP will be here 1 kbps, 2 kbps, 1 mbps. It won't bother about that. Just how many hops away, it will be sent packets to that only with the help of that route only. But RIP part, it will be select R1. But in OSPF and EAGRP, they calculate the best path with the help of formula. Okay, it will be calculate the formula here. 1 gbps is there, 1 gbps. Definitely, their path is like how many hops they'll don't bother about, but they will check the only bandwidth. This is the best path for RIP and EAGRP and OSPF. They'll be select likewise. Understood, everyone? This is our network layer. In network layer, up to network layer, anyone having any queries? And now move to
I
the
got one. Like, what's the purpose of the NIC network interface card?
network interface
Uh,
card.
the data
What?
link layer. Data link.
Yeah. See,
Yeah. What's
this
the
one.
use for that?
Yeah. Whenever in your system, if you are try to ping one loopback IP address, 127.0.0.1 or 127 dot 1.1.1 with this IP address 120 1 sorry 127 dot, just open your CMD in go search at here and open CMD command prompt. Just type this ping this IP address. Okay, ping this IP address 192.127.1.1.1. If your NIC card, it will be like in our old PCs nowadays. I am not seeing RJ45 connector PCs, but in your PCs like we have one RJ45 connector PCs are there, right? Earlier you have seen, and nowadays
Yeah.
also old PCs we have, that will be like connected to your LAN cable.
Mhm.
That is the NIC card. That one is NIC card.
Okay. Okay.
Understood?
Yeah.
If you are pinging this IP address, if it is not reachable, then your NIC card is faulty and you cannot reachable to network. Network also you cannot reachable. You cannot reach internet also. Understood? If NIC card problem, it will be work in layer 2 actually. Clear?
Yeah.
Good. Now transport layer. And the mainly the transport layer, it is kind of heart of the OSI model. The major functionalities here is it provide data delivery mechanism between application in the network. It will be directly like we have like apart from this we have a TCP IP model. It is they are directly connected to the application layer. But we have here TCP IP model transport session layer also, we have presentation layer also, but in TCP IP model, we have only uh, application layer, then host to host. This is a transport layer, then network layer, that is layer 2, and a network access layer. That is the reason I mentioned here. It will be deals with applications directly. Mechanism between applications, whichever upper layer, whichever application. For example, Facebook you open, the data will be transferred to the, it will be like UDP or TCP format. It will be comes. We'll discuss. Transport layer is a major function layer at OSI model. Majorly it will be identify the service. Mainly the transport layer is identify the service, and multiplexing and demultiplexing, and it there we call it as segment. Here we call it as like segments. Earlier we have like but in network layer we call it as packets. What data format is packets, but in transport layer we call it as segment. And segment in the sense layer 3 device is connected to one more layer 3 device. Whichever data is sending and receiving, this is we call it as a segment. This we call it as a segment. Understood? In between. This is the call it as a segment. If we have one more, this is connect, one more is router connected. This is segment. Understood? Whichever we are sending information, that is packets, we call it, and transport layer we call it, the information is, it will be carried with the help of segments. in trans in transport layer, the data flow like the segment, the data packets will be flow like it will be used the protocol which take care of data transport at transport layer are TCP, transmission control protocol, and UDP, user datagram protocol. With the help of these only, and TCP is a reliable protocol. It will be used three-way handshake, and UDP is unreliable protocol. It won't use any three-way handshake. We'll discuss more. We'll discuss about it. Just I'm giving brief introduction. What is the difference between? We'll discuss difference. First, we'll take difference of TCP, UDP. First, we'll take what is the difference here. TCP and UDP, and TCP is transmission control protocol and UDP is user datagram protocol. transmission control protocol, and UDP is user datagram protocol, and it's connection oriented protocols, and UDP is connectionless protocol, and it will be support acknowledgement, and UDP will not support any acknowledgement, and it's reliable protocol. TCP is reliable protocol. That is the reason we have three-way handshake, and we'll discuss protocol numbers later. For time being, we keep this information from your side. And for example of these TCP, like HTTP, FTP, SMTP, hypertext transfer protocol, whichever we are using browsing, whichever the information, that is like HTTP, and we'll use in FTP file transfer protocols like FileZilla, those protocols. But in our networking, we'll use like we'll connect it to one FTP server, will upgrade the devices likewise. And one more SMTP, simple network, a simple management transfer protocol like SMTP, and it is the management tool, management protocol, and we'll discuss it. And here we have a DNS. These are DNS, DHCP, TFTP, again TFTP file transfer protocol only. These will discuss. These are the UDP examples, and these are the TCP examples. Up to here, any queries? I'll explain you the three-way handshake. Up to here, any queries? Okay, we'll discuss three-way handshake. What is three-way handshake? In TCP, we have a three-way handshake. This is our client machine, and this is our server. PC1 wants to communicate server for any reason. First of all, this PC don't have IP address. It will be asked otherwise with the help of DHCP. We'll discuss any later. For reliable control connection purpose, first the PC will send hi myself PC1. It will be send hi myself PC1. Likewise. Then this server will reply, oh, you are the PC1. Oh, nice to meet you. Then hi, I got your information. Likewise, I got hi PC1. It will be send the likewise acknowledgement. Then PC1 give the reply. Thank you. So thanks something. Okay. For giving me reply. Likewise only, right? First, I'll send hi to one person, then he will give the reply, hi, how are you? Then thank you for asking hi. Likewise, the information will be happen. Now, in our network technology, we'll discuss here. First, ACK, this packet will send AC, sync. Sync packet, it will send sync. Then whenever the reply is giving reply time, then that time it will be thin packet, then it is giving. My screen is visible to everyone, right?
Yes.
Sync plus ACK, acknowledgement. First packet is sync, then sync at, then at ACK. Whenever the replying time. Thank you for sorry. Packet is like again acknowledgement. At first package is sync, and first packet is sync, then sync plus add, then acknowledgement. Synchronizing, syncing with, okay, syncing with that packet. That is the reason it is a reliable protocol. But now coming to UDP, it is the TCP protocol, transmission control protocol, TCP. Three-way handshake, three-way handshake, and this is a sender, and this one is receiver. Sender and receiver. Sender sending the packet, and this is a receiver giving acknowledgement. Receiver giving acknowledgement. And we'll discuss now UDP. UDP don't have any three-way handshake, user datagram protocol. It will be always like it won't bother about the information getting or not. It is not reliable. Only always sending the packets. It will be receiving or not receiving. It won't bother. Only always sending packets. Only sending. It won't bother about it. That is the reason this is an unreliable protocol. Only sending. It won't bother. Whenever you are discussing with your friend, he's taken some loan from your side. Whenever you are discussing, give me my amount, bro, give me my amount, he will don't bother about that amount. He will simply deny. Hello, 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 he will sell. He will send, right? Understood? Like example, like your video calls, Facebook, like WhatsApp video calls, and so. Am I audible to you, everyone?
Yeah.
Good. These all about our transport layer. And application presentation layer will presentation layer and a session third one is like, I'll give brief introduction for this. And session layer in the sense, whenever you are opening some browser, that time you multiple browsers you will open, right? It will be creating the session, and it will be maintaining the session. It will be terminating the session after the some while while minutes, it will be automatically terminate the session. Like your bank website is example. And the presentation layer here, you will be encrypted and decrypt the information. Encrypted and decrypt the information. Understood? And application layer is whichever you are using web browser, that is that for Facebook, it is application, this kind of end user, whatever is using, those are the application layer. Understood everyone? Any queries? Any doubts? If you have any doubts, we'll discuss. Tomorrow we'll discuss brief about session layer, transport layer, session layer, presentation layer, and application layer. We'll move forward the whichever our next account. Okay, TCP IP model. If you have any doubt, ask me. Otherwise, we'll end up the session.
Hello.
Hello. Tell me.
Yeah, actually today is my first class and I missed the previous videos.
I'll send you the link. I will
Okay.
give you the taking. No issue.
Thank you.
Good. Yeah, apart from that, any doubts?
No.